the 18th time since I started doing this video last Thursday. Came in, there was nobody here. And okay, I'll make videos. Spent all day making videos. Okay. Feel better? Okay, so I've got a 4x4 rectangle, you can see. Gave you the coordinates of the vertex, which are 16, negative 12, y is negative 12, x is 16, with the red dot. Then we can label all the construction lines. Pre-calculus, not knowing very well, and many people, is the coordinate plane. Okay, not sure how that happens, but I think it comes out because you just grab things in the calculator and don't ever think about the coordinate plane much. Okay, you need to understand the coordinate plane. Labeling these things is very helpful and getting a good picture of the coordinate plane as well as these functions. So we got all these lines labeled stuff. Then I asked questions. First of all, I asked them to do a table of construction points. And we've done that a couple times, and it's been assigned. So hopefully you make a table of construction, which is very easy. And if you don't understand how to do it, look at the long video. Okay, got a video that approaches an hour just for this. Okay, then this stuff comes later. If there are construction points, then we call this function g of x. So to find where g of x is 13.3, how do you do that? Well, g of x is the y value. X is the x value, right? Try to find the x value for this y value. So you draw a line y equals 13.3. Somewhere up there. Oh, there it is. Negative 13.3. Okay. And there it is. Y equals negative 13.3. And we find the point that line intersects the graph. We label the line x equals 15.25, which is what we estimate the x value would be at this point. Make your own graph, make your own estimate. Okay. That's how we estimate the value of x, the given value of y. That's how we solve the equation. G of x equals whatever. Well, then we make an estimate. G of 14.7, draw the line x equals 14.7, that's x, and see where that hits the graph, and there's our y value for 1.12.8. We do that and get an average rate of change on the interval 17.1 to 17.5. Here's your 17.1 line in the orange. Here's 17.5 line in the orange. Here's that interval, 17.1 to 17.5. Here are the points for those lines to graph, and this little orange triangle tells you what the rate of change is. Okay. So we ask for the average rate of change. We draw that same triangle bigger here. We label the points. Do the rise, do the run, we get this average rate of change, which is the delta y divided by the delta x, which corresponds to rise divided by run, which is the same thing as the slope. Look at the video for more explanation. The cogent function is f of x equals 1 over x. It's been shifted h units in the x direction, k units in the y direction. Well, how many? Well, it's been shifted. It's 0, 0 to the function. It's at x equals 16. This function, so your horizontal shift is 16. Your vertical shift is negative 12, because that's the y coordinate here. It's at the origin, it's moved to y equals negative 12. Vertical is shifted negative 12 units. Okay, so f of x minus h equals what? 1 over x minus h. And g of x is f of x minus h plus k, which is 1 over x minus h plus k. H is 16, k is negative 12. G of x is 1 over x minus 16. You add negative 12. Then you make the table using the g of x function. And honestly, evaluate these, and on the test, you show me how you do it. And you get your numbers there, plug them into that function. You plug them into this. And here are the numbers you get. And look, they match numbers you get in construction points, which convinces you that this really is the function. Q of x is 1 over x minus 16 plus negative 12. All right. So we have that. And that's pretty much it. That's where you put it together. It's got the problem like this. There might be one problem like this, maybe two. You're going to have to rethink the test a little bit. But the problems that I set out, the sample problems, the problems are going to change. Now you get different numbers in the sample problems, and you don't get every sample problem. Okay. Only 7 problems and 6 problems, I think, 7 get now on the test, whereas there are about 15 sample problems. But you got to know how to do them all, because you know which ones are which one. It might be different on different tests. So you got to compare everything. All right, well, that's just an example. So in the first video you see in that set of 4 things on the test, that's a quick summary of what I spent probably 45 minutes in the video explaining in detail. Okay. Telling you exactly what you need to do, what you need. You already pretty much know. You probably don't need that. Maybe you only need the text explanations. Then start at the case page, okay? But then you got a short video, about 50 minutes, compared to the close to 3 hours in the original. Okay, condensed down. I just did the same thing I did here. Then a little more detail maybe than I did on all the problems. Okay. So if you get it from that, it's only 50 minutes of video. Spend the time, take notes. And if you don't understand something, then you know that you have longer videos to look at. And then the third set is still condensed from the first set, but it's about, yeah, it's longer than the first video you run into. And then you have 4th set, which is the full videos, and that all runs to 3 hours. Probably don't spend 3 hours, but probably don't need to, because some of the problems you probably know how to do and you can skip through. Okay, makes sense? So you have that as a resource. You also have your assignments, your notes, everything you've done in class, everything you got out of class. Okay. But the video should give you a pretty good sense of what you need to do, what you need to know, and how you need to do it on the test. So that's all I'm going to say about those. I'm done. For your sake, because there's other stuff we got to do. Okay, now I'm going to pause a second and take a look for the first time in 5 days at the open math assignments. I just got the ability to do that. Recording, but you know, it said y is directly proportional. DIR stands for directly proportional to x if and only if y equals kx for some constant multiplier k, constant number k. Okay. So the question is, what do you have to multiply x by to get y? You show me with your fingers. 6 times 3 is 18. There you got it. Now there's a more formal way to do this though, and you kind of need it because we also have inverse proportionality and proportionality of the square of the cube and variation and all that stuff. But open math will, I guess, as well. Okay. Again, let me just say, make sure you absorb this. This is very powerful. It's one of the most powerful things you learn in mathematics. It's proportionality. Okay. And it's not taught. Open Math does a pretty good job, but you're going to have to retain it to make use of it. So learn it in such a way that you retain it, write things out completely, upload what you're writing, and hopefully I'll be able to see it. Okay, I've tried to access Open Math, but it seems to be working all right. Okay, I mean, what I'm seeing. Okay, anyhow, so you multiply this by 6 to get 18. Now, my question is now, what would your value of y be when x is 5? Well, you just told me that multiply 3 by 6 to get 18. And this multiplier, this k, is the same as long as proportionality holds. It means you're going to multiply 5 by 6 and get 30. Okay, same multiplier. Now let's write it out formally. Okay. Y equals kx because you have a direct proportionality. So 18 equals k times 3, right? Because y is 18 when x is 3, this has to work. And y is 18 and x is 3. That allows you to solve k. You solve this equation and you get what we already got, that your multiplier is going to be 6. Since the multiplier is 6, we now know that y equals 6x. So if I give you a bunch of different x values, you're going to be easily able to calculate the y values. Now 6 is an easy number to multiply by, you can just use common sense, but you want this formal procedure, and you're going to see why in a minute. X is 5. You place x by 5, 6x is going to become 6 times 5. That's your y value. It's going to be 30. Pretty simple, right? But you want to follow the steps when you get into other proportionalities. Okay, so what would you say if y is proportional to x squared? Instead of y equals kx, what would you write if it's directly proportional to x squared? Okay, y is directly proportional to x squared means kx squared. Okay. Let's say again y equals 18 when x equals 3. Just use the same numbers we're used to. Okay. What do you do with those numbers? You plug them in. You write 18 equals k times 3 squared. So you get 18 equals k times 9. You get k equals 18 over 9 equals 2. Y equals 2x squared. All right. Now you could have figured out what the multiplier was If you square 3, you get 9. What would you multiply 9 by to get 18? Yeah, it's 2. But it gets a little harder to think about the next steps when you have that square in there. And this is where you want to have procedure that you can then apply to any proportion. Okay, so y equals 2x squared. Y x equals 5. Well, you still could, I think, through it intuitively. If I square 5, I get 25, and my multiplier is 2, so I'm going to get 50. But still, that's a more complicated thought. And it's one that's much easier to trip over than the kind of thing you do. You just do this to. X equals 5, we get y equals 2 times 5 squared equals 3 times 25 equals 50. And you've got it in a form where it's easy to check instead of writing out a bunch of words. Okay, that's good to write out the words too, because that's how you reinforce it. I encourage you to do both on your homework. As it helps you time. Okay, that makes sense? Pretty straightforward. Shouldn't be as difficult as people usually find it, but I think experience it for some reason. Okay, well. What could be inversely proportional to x? Well, y equals 18 when x equals 3. What's the next thing you're going to do? Go ahead and do it. Give you a couple of minutes. Look around and see if you're doing it. See what I need to say next. Couldn't see everybody's work. That's all close. And it looked pretty good. Y equals 18 when x equals 3. 18 equals k over 3. So 3 times 18 equals 3 times k over 3. And I really encourage you to write down these steps. Because when it becomes all symbolic, and you're not really in the habit of writing out these steps very clearly, saying what they mean, you're going to trip on them, or you're more likely to trip on them. Okay. So how that gives us 54 equals k. Of course, 3 divided k. Okay. Now, I'm writing all these words for a reason because they logically connect everything. If you're skipping words, you're skipping understanding when you write these out for homework. Okay. Now, if you've done half a dozen problems, all the words, and you get it right, and you really have the hang of it, and you know, I'm looking at your homework, I look, okay, well, I'm not having any explanation here, but yeah, it was real good before, so I think they understand. Right? Okay. Thus, uh, so if x equals, what are we doing? X equals 5. Yeah. Write it out, just be sure, it's pretty obvious. Just be sure you're on track. We get okay, if you want to see how big this is, we divide it out to 10/4 and 10.8. What the number is, okay? 54/5 is an okay solution. But if you're gonna put it on a graph, for example, you're gonna want to get a number. Or divide it out, okay? Well, that's pretty much it. Now, if I said y was inversely proportional to x cubed, well, everybody pretty well wrote down y equals kx squared, and I said directly proportional to x squared. Inversely proportional to x cubed means it's going to be y equals k over x cubed. Okay, so it's either direct, where k is multiplied by the x, or inverse, where y k is divided by the x. Okay, pretty much it. Except the intuition you gain by doing the problems, and open math has a lot of good problems. Can everybody access open math?